Look closely at humanity. For centuries, human beings have divided themselves based on a superficial trait only a few millimeters deep. What if the colors we wear are simply ancient biological spacesuits? Suits tailored not by hierarchy, but by the fierce power of a single star, our sun. Today, we journey back in time to uncover the true history of human skin pigmentation. We will discover how our earliest ancestors transformed from fur-covered hominids to a stunningly chromatic species. This is the story of the chromatic ape, a story uniting every person alive today under the same brilliant sky. Our evolutionary story begins roughly 2 million years ago in the sweltering heat of equatorial Africa. If you observed our earliest ancestors, you would notice they were covered in a thick coat of dark hair. Beneath that fur, much like modern chimpanzees, their skin was quite pale. But the environment was shifting. Lush forests were gradually drying out, transforming into vast, open savannas. To survive, our ancestors had to adapt. They had to hunt and scavenge in the relentless midday sun, a time when most other predators sought the shade. To accomplish this, they evolved an incredible new superpower: endurance running. Unlike large cats that sprinted for short bursts, early humans could jog and track for miles, pursuing prey until the animals collapsed from heat exhaustion. But there was a biological catch. To keep their expanding brains from overheating inside their skulls, they needed a radical cooling system. Early humans developed millions of sweat glands spread across their entire bodies. However, a thick coat of fur traps sweat, rendering this evaporative cooling system completely useless. The solution was evolutionarily drastic. Over hundreds of thousands of years, we shed our thick hair and became the naked apes. But in solving one problem, we created another. Shedding our fur exposed our pale skin to a dangerous, invisible threat: the intense, unforgiving ultraviolet radiation from the equatorial sun. We traded overheating for a much deadlier problem. The naked ape desperately needed a shield. You might assume the main evolutionary danger of unshielded sun exposure was skin cancer. While lethal, melanoma typically strikes later in life, well past a person's reproductive years. Evolution coldly prioritizes adaptations that keep you alive just long enough to reproduce. The immediate, existential danger of ultraviolet radiation was far more insidious and directly targeted our ability to multiply. Ultraviolet rays easily penetrate pale skin and destroy a crucial B vitamin circulating in our blood called folate. Folate is essential for DNA synthesis and fetal development. For pregnant women, a lack of folate leads to devastating birth defects. For men, it dramatically decimates sperm production. Without adequate folate, early humans simply could not reproduce. Under the blistering African sun, pale-skinned hominids faced rapid extinction. Enter our biological savior, melanin. Melanocytes are specialized cells in our skin that manufacture dense, dark pigment granules. As early humans lost their fur, individuals who naturally produced more melanin had a built-in physical sunscreen. This remarkable dark pigment absorbed and scattered destructive ultraviolet rays before they could break down the vital folate coursing through the bloodstream. Nature heavily favored this darker pigmentation. By roughly 1.2 million years ago, our ancestors living in high ultraviolet equatorial Africa had evolved deeply pigmented, dark skin. This was our original human spacesuit, a flawless biological adaptation for thriving beneath an intense sun. For the vast majority of human history, every single human being walking the earth was dark-skinned. It was the biological baseline of our entire species, the protective armor that allowed humanity to survive and eventually flourish across the African continent. Fast forward to about 70,000 years ago. Driven by climate shifts and the pressure of growing populations, bands of anatomically modern humans began to leave Africa. They embarked on the greatest migration in planetary history, pushing into the frigid forests of ancient Europe and the steppes of Asia. As these pioneers ventured further north, away from the equator, they entered alien environments. The days grew shorter, The thick canopy of the northern forests blocked out the sky, and the sun became incredibly weak. In this new, shadowed world, the deeply pigmented skin that had been an absolute lifesaver in Africa suddenly became a severe liability. The melanin shield was doing its job far too well, blocking out not only the harmful ultraviolet rays, but also the vital ones. The sun is not just a destroyer, it is also a creator. We desperately need a specific type of ultraviolet light, known as UVB, to penetrate our skin and synthesize vitamin D. Vitamin D is just as crucial to human survival as folate, but for entirely different reasons. It is the key that allows our bodies to absorb calcium from our diet. Without vitamin D, our bodies cannot build or maintain strong bones. Furthermore, it plays a massive role in maintaining a robust immune system, vital for early humans facing new, unknown pathogens in colder climates. In northern latitudes, dark-skinned humans could not absorb enough weak sunlight to produce adequate vitamin D. The consequences were absolutely devastating. Children growing up in these dark environments developed rickets, a cruel disease that softens and permanently warps the bones, often crushing the pelvis and making childbirth impossible for women later in life. Immune systems failed, making entire populations vulnerable to infections. Once again, humanity faced an existential threat, not from too much sun, but from too little. The evolutionary pressure was immense, and the biological response was beautiful in its simplicity. Over thousands of years, as populations settled in northern regions, natural selection favored individuals with genetic mutations that reduced melanin production. As skin became paler, it allowed the scarce, weak northern sunlight to penetrate deeply enough to jumpstart vitamin D synthesis. The biological spacesuit was adapting to a completely new atmosphere. This process did not happen overnight, nor did it happen just once. As humans migrated across the globe in various waves, populations in low sunlight environments independently evolved lighter skin tones over and over again. Conversely, when populations migrated back toward the equator or found themselves in high-altitude environments with intense solar radiation, their skin darkened once more to protect their precious folate reserves. Look at the indigenous populations of the world before modern transportation blurred the lines. Their skin colors form a perfect, continuous gradient that beautifully mirrors the intensity of the sun's ultraviolet rays globally. The darkest skin is found near the equator, while the palest skin is found in the highest northern and southern latitudes. There are fascinating exceptions, of course, that perfectly prove the rule. The Inuit people of the Arctic maintain slightly darker skin than one might expect for their extreme latitude. Because their traditional diet of marine mammals is incredibly rich in natural vitamin D, they did not need to lose their melanin entirely. They were eating their vitamins instead of photosynthesizing them. This exception proves that skin color is a fluid, dynamic biological trait. It is a highly sensitive environmental dial, constantly turning back and forth across thousands of years to find the perfect equilibrium between protecting folate and producing vitamin D. We are all the chromatic ape. Every single hue represents a spectacular evolutionary victory. It is the visible evidence of our ancestors' incredible journey across this planet, adapting to every harsh environment they encountered. The colors we wear are a testament to our shared resilience, a living map of our collective history painted directly across our skin. The next time you look in the mirror, remember the journey. We are all children of the sun, shaped by its light and bound together by the biology that makes us wonderfully human.